Hello, this is the lecture number 4 for the chapter Triangle of class 9. We're discussing the second exercise, and question number 8 is you have to prove that in an equilateral triangle all angles equal to 60 degree. This is a theorem, you can say that. So what is given? There is an equilateral triangle ABC and you have to prove that angle A, angle B and angle C is equal to 60 degree. Now because AB is equal to AC, it is given, and then we can say that angle B is equal to angle C. Now because these two sides are equal, so we can say that angle C is equal to angle B, angles opposite to equal side. Now because AB is equal to BC, because in equilateral triangle it is given. Now because AB is equal to BC, then angle C will be equal to angle A, angles opposite to equal side. These two sides are equal, this angle equal to this. These two sides angle C will be equal to angle A, this. Now because angle C is equal to angle B and angle C is equal to angle A, so we can say that angle A, angle B and angle C, they are all equal to each other from step number 2 and 4. Now we can let that these three angles be equal to x because they are equal, and in triangle ABC all the sum of all angles is equal to 180 degree. So replace x in place of angle A, angle B, angle C because they are equal. So 3x is equal to 180, so x will be equal to 60. So we can say that angle A, angle B and angle C is equal to 60 degree. That is, all angles of an equilateral triangles are equal to 60 degree. Now in exercise 7.3, you have to prove that it is given that in triangle ABC, in which AB is equal to AC, and in triangle DBC, that is BD is equal to DC, it is given. And first of all you have to prove that ABD is congruent to ACD, then you have to prove that ABP is congruent to triangle ACP, and then you have to prove that AP is bisector of angle A as well as angle D. Either this angle equal to this or this angle equal to this. You have to prove that AP is a bisector, and then you have to prove that AP is a perpendicular bisector of BC. This you have to prove. Perpendicular bisector means 90 degree and bisect the side. So first of all, in triangle ABD and ACD, in these two triangles, AB is equal to AC, BD is equal to DC, and AD is equal to common in both the triangles. So we can say that ABD is congruent to triangle ACD by SSS, congruence rule. Now we can say that angle 1 is equal to angle 2, corresponding part of congruent triangle are congruent, and angle ADB is equal to ADC, corresponding part of congruent triangle are congruent for both. Now because this angle is equal to this and this angle is equal to this, so we can say that AP bisect angle A and angle D. This is the main thing you have to prove. Now in triangle ABP and ACP, AB is equal to AC, it is given. Angle 1 is equal to angle 2, we have just proved that they are equal. We have just proved they are equal, and AP is common. AP is common. So in this triangle ABP and ACP, they are congruent by side, angle, side. This side is equal to this angle is equal to this, and AP is common. These triangles are congruent by side, angle, side. Now because these two triangles are congruent, ABP and ACP, so we can say that BP is equal to PC, corresponding part of congruent triangle are congruent. Angle 3 will be equal to angle 4, again corresponding part of congruent triangle are congruent. Now because these are linear pair and these are equal, these are linear pair and these are equal, angle 3 and 4, so it means angle 3 and angle 4 will be equal to 90. 3 plus angle 4 equal to 180 degree, and both are equal. So what can we say? That these should be equal to 90 degree. So it means that AP is perpendicular to BC and BP is equal to PC, that is AP also bisect BC. So we can say that AP is the perpendicular bisector of BC. This you have to prove in this question. So in this question, many things you have to prove. That is AP bisect angle A and angle D. So we have proved that angle 1 is equal to the angle 2 and angle ADB is equal to angle ADC by corresponding part of the congruent triangle. So they are bisecting the angle A and angle D. Then AP is a perpendicular bisector. For this we have proved that BP is equal to PC and AP is perpendicular to BC. This is the good question. Now in question number 2 of this exercise, it is given that there is a triangle ABC, but rather triangle ABC is isosceles triangle in which AD is perpendicular to AB is equal to BC and AD is perpendicular to BC. Now you have to prove that AD is the perpendicular bisector, or the AD bisect BC. AD is perpendicular to BC and AB is equal to AC, and then you have to prove that AD is bisect BC, that is you have to prove that BD is equal to DC, and you have to prove that this angle is equal to this. You have to prove AD bisect angle A. Now we'll prove that a triangle ABD and ACD are congruent. How can you prove that? That is angle ADB and ADC are both 90 degree and AB is equal to AC. It is given they are equal and AD side is common. So by 90 degree hypotenuse and one side, by RHS they are congruent. By RHS they are congruent. 90 degree hypotenuse and AD one side is common. So these two triangles are congruent. ABD and ACD are congruent by RHS. Now because they are congruent, so BD is equal to DC. BD is equal to DC, corresponding part of congruent triangle are congruent, and therefore AD is a perpendicular. It is given that bisect BC, and this is equal to this. BAD is equal to CAD, corresponding part of congruent triangle. For both, the same thing is there. So therefore AD bisect angle A and bisect the side BC. Now question number 4 you have also done in the last exercise, but you have to prove that the triangle is congruent ABC, altitude BE and CF are equal, and you have to prove that they is isosceles triangle. By RHS congruence rule you have to use in here. In the last question you have proved that ABE is congruent to ACF, but here we will prove that FBC is congruent to ECB by RHS. So what is given in a triangle ABC, altitude BE and altitude CF are equal. Altitude means the line segment from the vertex to the other side is perpendicular. Now in triangle BFC and CEB, angle F is equal to angle E, both 90 degree. BC common in both the triangles, and CF is equal to FC is equal to BE. It is given that the altitudes are equal. The triangle BFC is congruent to CEB by RHS congruence rule. Now because these are congruent, so we can say that angle B will be equal to angle C, corresponding part of the congruent triangles. Now these two angles are equal, then their sides opposite to also are equal, that is AC is equal to AB, side opposite to equal angles. So the triangle ABC is isosceles. So this question you have already also done in last exercise. There you have we have proved that triangle ABE and ACF congruent, but here we have proved that BFC and CEB are congruent by RHS rule, and the last exercise we have used the AAS congruence rule. Now in question number 3 it is given that in question number 3 there is a triangle ABC and triangle PQR, and AM and PN are the medians. So read it very carefully. AB is equal to BC, AB is equal to PQ, and BC is equal to QR, and the median AM is equal to median PN. It is given, and first of all you have to prove that triangle ABM is congruent to PQN. Then you have to prove that triangle ABC is congruent to triangle PQR. After that you have to prove. So to prove it, first of all you can write BC is equal to QR because they are given that they are equal, and because AM is equal to PN are medians. So it means M and N are the midpoint of BC and QR respectively. So in place of BC you can write twice of BM. In place of QR you can write twice of QN because N is the midpoint of QR. So you can cancel out 2 here. So BM is equal to QN. BM is equal to QN. AB is equal to PQ is given. AM is equal to PN is given. So triangle ABM is congruent to PQN by side congruent rule. AB is equal to PQ is given. AM is equal to PN is given, and we had proved that BM is equal to QN because BC is equal to QR. The half line segment will also be equal. This we have proved. Median is a line segment which join the vertex and the midpoint of the opposite side. So M and N are the midpoints. So A, B, M and P, Q, N are congruent by SSS rule. So angle B will be equal to angle Q. Angle B is equal to angle Q, corresponding part of the congruent triangles. This. Now in triangle A, B, C and PQR, AB is equal to PQ. It is given. Angle B is equal to angle Q. We have just proved. And BC is equal to QR. It is given. So triangle ABC is congruent to PQR by SAS congruence rule. So this is the good question. Now in question number 5, it is given that there is an isosceles triangle AB is equal to AC and AD is perpendicular to, AP is perpendicular to BC. It is given and you have to prove that angle B is equal to angle C. That is, you can say that we are proving that the side opposite to equal angles are equal. So in triangle ABP and ACP, angle P is equal to, that is APB is equal to angle APC, both 90 degree, and AB is equal to AC, it is given, and APAP is common. So triangle ABP is congruent to ACP, RHS right angle, hypotenuse, and one side is equal. Now because these two triangles are congruent, so we can say that angle B will be equal to angle C. Corresponding part of congruent triangle are congruent. So it is a simple question. Now we'll prove two theorems here, which you should do first of all, starting the exercise second. Now you have to prove that the angles opposite to equal sides of the triangle are equal. In triangle ABC, AB is equal to AC, and you have to prove that their opposite angles are equal. That is, angle B is equal to angle C. Sides equal, then their opposite angles are also equal. So how do you have to prove it? You have to prove it by doing a construction here. Draw AD perpendicular to BC. You have to do the construction here. AP, AD perpendicular BC, you draw it perpendicular. You have to draw the construction by the dotted line. Now you can easily prove that the two triangles are congruent. You can easily prove that these two triangles are congruent because in triangle ABD and ACD, angle ADB and ADC are equal, both 90 degree. By construction, AB is equal to AC, it is given, and AD is common. So triangle ABD is congruent to triangle ACD by right angle, hypotenuse side, RHS, ACD and ABD and ACD. Now because these two are congruent, so angle B is equal to angle C, angle B will be equal to angle C, corresponding part of congruent triangle are congruent. So we have proved the theorem that the angles opposite to equal sides are equal. Now this is the opposite theorem, and if the angles are equal, then you have to prove that the side opposite to them are also equal. So there is a triangle ABC in which angle B is equal to angle C, and you have to prove that AB is equal to AC. So again you draw a construction here, draw perpendicular to AD, perpendicular to BC. Now you can easily prove that triangle ABD and ACD are congruent by angle B is equal to angle C, by it is given, and angle ADB and angle ADC both 90 degree, and ADAD is common to both the triangles. So by angle side angle, the triangle ABD and ACD are congruent. Now because ABD and ACD are congruent, so we can say that AB is equal to AC, corresponding part of congruent triangle are congruent. So we have proved that these two theorems, that the angles opposite to equal sides are equal and the side opposite to equal angles are equal. Okay, thank you.